I have modified the question slightly, and in this question we will try to find velocities of different points in the mechanism that is given over here. Okay, so we will take the value of rotations to be the same, and we will and for this rotation for the same dimensions we will find a number of velocities. We will find velocity of point A, velocity of the midpoint of point OA, linear velocity of the slider at B, and the velocity of midpoint of AB, and the velocity of point E. And then we have to find the point on BE where the velocity is minimum, and also we'll have to find the angular acceleration of the coupler AB. So all these things we will have to find, and for this we need to understand what the velocity diagram is and how to draw the velocity diagram. Alright, so before going anywhere, first we'll have to complete the position diagram of this particular thing. And we can see here that the maximum length is 160. Okay, so if we okay, so if we see the maximum length that we can draw over here, that's around 160. Okay, so let's take the scale here. Okay, so we'll have to use some scale here, because in true shape we won't be able to draw the particular thing, right? Yep, so let's take a new sheet and start doing our calculations. So we have to use a scale. Fine, so we can draw a maximum of 160 mm on our drawing sheet, and the maximum length that is involved in the position diagram is 1600 mm. So this is the scale we will use. 1600 mm is the actual length, and we will draw it as 160 mm in our drawing. Okay, so let's draw a horizontal line here, and then we have to start by drawing this angle over here. So if you see the diagram here, the angle has been given as 60 degrees. So let's go ahead and take a line at an angle of 60, and its length here is 480, and 480 length, we will 480 mm length. If you want to draw this in drawing length, you can see 10 is reduced here, so we will have to draw it as 48 mm. So let's go back here. So 60 degree angle we have fixed, length we need to draw as 48. So this step you need to do using the protractor. Okay, so once you have drawn this, the next step is to mark a distance of 1600 mm from this point. So now you have seen here that when we want to draw 1600, we will have to draw it as 160 mm. So let's come back. So in order to draw 160 mm exactly, we will have to take a circle of that much length. Okay, so that's meeting somewhere here. So let's extend this, and this intersection point we will need it. Okay, so coming to name the points, we'll have to name these points. This point is O. Okay, this point is A, and this point is B. Alright, and then we have to extend it backwards by a distance of 450. So coming again at 450 mm, when we draw it, we'll have to reduce 10, so we'll have to draw it as 45 mm. So let's draw a circle with this point of center 45, and we'll have to extend this line backwards. So now I can see it's becoming a little difficult for me to place it in the A4 sized sheet that I'm using. So these are the margins, so it's still within the margins, so let's use it like this. Next we just need to name this point as E. Alright, so now you can see that we have got the position diagram. So position diagram we have got with this scale. Okay, so the scale is divided by 10 when you move from left to right. So So same way, if you want to move from right to left, you will have to multiply by 10 when you want to move from right to left. So if you get a measurement on the diagram and you want to convert it into actual length, you will have to multiply by 10 instead of dividing it. So next, let's come back over here. Come on, what happened? Stuck. Come on. I don't know, something's happened. Oh, come out. Okay, so now that we have the position diagram, we can start drawing the velocity diagram. Okay, so this scale is for the position diagram. So let me write this at the top. So position diagram. So for position diagram, this is the scale. Now we have to take another scale for velocity diagram. Velocity, okay, diagram. And for doing the velocity diagram, first thing we have to do is we have to find at least one of the velocities. So if you come back here to the question, we have been told that the crank OE is rotating at 200 rpm in counterclockwise direction. Now that information we need to use in order to find the velocity of A. So velocity of A, fine. So that is given as omega times the length OA, and omega we know it's 2 pi n by 60, because the angular velocity has been given in terms of rpm, the rounds per minute. The rounds per minute, if you substitute here, we will get the value in radians per second. So let's go ahead and find this, because need a calculator. Okay, so 2 into pi into n has been given as 200 and divided by 60. This needs to be multiplied with the length OA. So when we have to multiply the length OA, so this length here is OA. Okay, this one here is AB, this here is A to E. All right, so we have to multiply the length OA. So we have to take the actual length and not the drawing length. Okay, so 480 mm is what we have to take up. So 480 mm, so OA length is 480 mm. So we need to convert this into meters. So we will get 0.48 meters. So that's the value we have to use over here. So coming back here, so we have to multiply 0.48. Yes, 0.48. So when we do this, we get the value as 10.05. So 10.05 meter per second. This is the linear velocity of A. So now once again we have to take a scale for the velocity diagram. Okay, so first is the velocity of A. Its actual velocity is 10.05 in meter per second. So this we need to convert into some convenient length that we can easily draw on our sheet. So my suggestion is to go for at least either 50 mm or 80 mm, whichever is convenient for you. The more you take, the more accurate you will get the result, but at the same time it will be more difficult to fit it on the diagram, on the sheet that we have provided. Okay, so make the best choice depending on what best suits you. So in my case, I'll just go with 80 mm. So this is my scale. So when we have to go from left to right, what we have to do is we have to multiply this with 80 by 10.05. Okay, so this is the scale that we are using. So every value of velocity that we want to convert into diagram length, we have to multiply this. Okay, so coming back here, we now need a line perpendicular to this, because velocity of A will be perpendicular to OA, and if we look at the diagram, it's rotating in anti-clockwise direction, so the velocity is going to be in upward direction. So let me take a copy of this, rotate it by 90 degrees. So this is my diagram, and it will be going in backward direction. So this side we will call it as small o. This is the point which is fixed, and this length we have to draw it as 80 mm. That's what we decided. So this length should be 80. Okay, so make it 80 mm. So we have to draw it at a convenient distance over here, so that we can get the other two diagrams. Because the velocity of b is going to be horizontal, we will get a horizontal line over here. So now we know that b is moving in horizontal direction with respect to the fixed point, so we just need to draw a horizontal line over here. Fine. And then the velocity of a with respect to b, or b with respect to a, that will be perpendicular to this line. So we need to take a copy of this, and we need to rotate it by 90 degrees, because we need a line which is perpendicular to this. Okay, so if you measure the angle over here, we need this angle to be 90 degrees. So you can use your protractor when you want to do that. Okay, so this point here is a, and because these two lines are meeting over here, this point here, we will get it as yes. Okay, so this is the velocity diagram. This is the velocity diagram, and we have taken this as 80 mm. And if you measure the length of other distances, we will get the drawing lengths, and these drawing lengths we have to again convert them back into, okay, so these, oh god, come on, I don't need this. Alright, so next, suppose we need velocity of yes, we're getting the value over here as 18.05 mm, and now we need to convert it back from right to left, so we have to divide this value instead of multiplying it. So let's go ahead and do that. So 80.05 divided by 80 by 10.05. Okay, so this will give us 10.06 meter per second. So that is the velocity of our slider, and if we want to find the velocity of a with respect to o, sorry, not a with respect to o, a with respect to yes, or yes with respect to a. Okay, so both these values will have same magnitude, the direction will be opposite, so you'll have to take this measurement over here. So 41.45 mm, then convert it back. Okay, so here instead of okay, so instead of this value we have to take 41.45. So we're getting 5.21 meter per second. So these are the velocities. So but when we look at the question, what are the velocities it is asking us to find? First is asking the velocity of a, so that we have found over here. Then it is asking the velocity of midpoint of OA. So if you want to find velocity of midpoint of OA from the diagram, we just have to find the velocity of the length of midpoint. So midpoint to this, so this will give us the velocity of the midpoint of OA. Fine. Similarly, if you are asked to find the velocity in any ratio, you can take that particular ratio on this line, and that point will be moving with that particular velocity. Okay, sorry, you have to find the velocity of midpoint of OA. So OA means we have to take midpoint of OA. All right, so this is the length that we're getting, that is 40. So of course, obviously it's going to be half of this. Fine. So let's take this point, the midpoint of OA. Let's give it some name. Let's call it as yum. So if you want velocity of yum, that's measurement is 40 mm, and of course when you convert that, it will be half of this, so 5.025 meter per second. Next, we've been asked to find, okay, so b1 we have found, and then linear velocity of b. Okay, so this I've written as slider, it's actually b. Okay, so that's the velocity of b. So this is c bit, and then d bit is asking the velocity of midpoint of AB. Okay, midpoint of AB. If you want to find velocity of midpoint of AB, so okay, here this is B. Midpoint of AB, if you want to find velocity, because it's going to be halfway through that length, midpoint of AB. So this is the velocity of the midpoint of AB. So if you want to find the d bit, let's call this point as n or something. Okay, n point. Okay, so velocity of n, if you want to find, we're getting its measurement as 20.7. so again you need to use this over here and substitute 20.7. we're getting 2.6, so 2.6 meter per second. That is the answer for d bit. Now linear velocity of the point E. Now E, you can see it's on the extended side over here. Okay, so BA has been extended to get the point E. So similarly here, small BA we need to extend. So BA we need to extend in order to get the point E, and the ratio needs to be maintained the same. So let's say AB by AE, this ratio needs to be maintained with the velocity diagram. Okay, so AB length, capital AB length, we know it is 1600, and capital AE length, we know it is 450, and capital small AB length, we can see we have measured it, it's 41.45, and AE, small AE length, is what we are interested in finding. So we will get it like this, the 450 divided by 1600. So let's see what that length comes out to be. Alright, so 41.45 into 450 divided by 1600, 11.66. So this is the length we need to draw over here. So we need to extend BA. So small BA needs to be extended. So let me take a circle of 11.66. This is the length by which we need to extend it, because this measurement needs to come over here, right? And you can see here, this is the length by which we have extended it. So when we extend it by that length, this point that we get here is point E. Okay, and we want the velocity of E with absolute velocity of E, so we need to join that with this point over here. Okay, so now we need to measure this distance. So when we want to find velocity of E, we're getting the measurement as 83.75. this we need to convert again, so 83.75, so we're getting 10.52, so 10.52 meter per second. That is the velocity of E. That is the velocity of E. And that was E bit. Again, next we want point on BE where the velocity is minimum. Okay, so point on BE where the velocity is minimum. Fine. So if you join any point on this length, if you join with this point O, we will get the velocity of that point and the link BE. I mean, we know that the shortest length here will be perpendicular, so we will have to take a perpendicular here. Okay, so we will have to take a perpendicular, and that length will give us the smallest velocity, and this point here, okay, that point here will give us the point where the velocity is minimum. So let's measure this. Okay, so 26.55 is the length over here. So that length we need to again convert. So let me call this point as something. Okay, this is the point where the velocity is minimum, so let's call it as F G something. Okay, so G point, G is the point where the velocity is minimum, and we have to find the capital BG. Capital BG is the length we want to find, and BA, capital BA length, we know that's should be in the same ratio as small bg by small ba. All right, so this will go and get multiplied over here. Let's do that, and we get small bg length. Small bg length is 20.85 into capital BA, and BA length we know it is 1600 divided by small BA. Small BA length we know it is 41.45. So we're getting 804.83. So this is the length capital BG. So if you want to find that point, you have to mark the point from B, and length 804.83. All right, so we have to again convert this. 804.83. 804.83 is the actual length, so we have to again convert it. So divided by I, so 80.48. We need to draw 80.48, and this point is the point G. This is the point G where the velocity is minimum. This is where the velocity is minimum. Lastly, he's asking, okay, let's go with X, the angular velocity here. Angular velocity. Now here, angular velocity, we know the relation. If you want angular velocity, the relation is velocity divided by the radius. Okay, and here we want the velocity of AB, angular velocity of AB. So it will be velocity of A with respect to B, or B with respect to A, divided by the length AB. This is what we need. So velocity of A with respect to B, we know it's 5.21 meter per second, divided by the length AB. AB length we know it's 1.6 meters. So that will give us the angular velocity. Let's go ahead and do that. 5.21 divided by 1.6, so 3.26. Okay, we are getting in radians per second. So that's the angular velocity. That's the angular velocity of the link AB. So these are the scales that we have used, and these are the values of values that we have calculated over here. You can pause the video if you want to take a note of it, and this here you can see is are the diagrams. First we have the position diagram, and then we have the velocity diagram. So you can pause this to take note of whatever you want to note it down. So this is how we will be able to draw the velocity diagrams. In the next video we will take up the acceleration diagrams, and if you like this particular video, and if you want to stay in touch for the next video, please subscribe to the channel and please share it to among your friends if you feel that